If I said I have a server with 150 terabytes of storage in it, you'd probably picture something like this. But damn, that'd be boring, right? So how about we put 150 terabytes into here? And not only that, let's put 150 terabytes worth of solid state storage in here and make a compact, quiet, power efficient storage server with enough high speed storage to satisfy the nerdiest of nerds. Now, the immediate question you're gonna ask is why? Well, there's an extremely good reason I'm doing this. It's actually because, so the base of the system isn't anything too crazy if I'm being honest. That doesn't mean it doesn't have some cool tricks up its sleeve and a sprinkle of jank though. The heart of the system is a 6-core, 12-thread Ryzen 5 7600. I chose this processor for the very specific reason that I used it in a previous build. On a serious note, these newer Ryzen chips make solid home server CPUs now that they've added integrated graphics, which just makes things a lot easier since we don't need to waste a PCIe slot or PCIe lanes with a GPU, and we get hardware transcoding. Although Plex doesn't play super well with AMD GPUs. Unpopular opinion time, these days hardware transcoding isn't really necessary. The chances the device you're streaming to doesn't support the default codec of your media is pretty low. Sure, transcoding also comes in handy when you want to stream a lower bandwidth version, but Our motherboard in here is an ASRock B650M PG Lightning. There was only really one requirement I had when picking out a motherboard, and that was that it needed to support 4x4x4x4 bifurcation on one of the X16 PCIe slots. You'll see why in a bit. I probably could have gone with an ITX board, but since the chassis supports MATX boards and those are generally more affordable, we went with that. For RAM, we have a modest 32 gigabytes of DDR5. Our boot drive is a 2TB SSD to give us somewhere to host VMs, and of course we have our extremely unmodest 30 terabyte Solidigm D5 P5316 drives, 5 of them, for a total of 150 terabytes of raw storage. Solidigm sponsored this video, and unfortunately, no, I don't get to keep the drives. These are U.2 NVMe PCIe Gen 4 drives that are designed for high capacity and high endurance. Typically, you see these in data centers or in highly specific workstations. Today, you get to see them in a bald YouTuber's home server. Lucky you. Clearly, this is overkill for my use case, but you can't deny that it's cool. I mean, 30 terabytes per drive is more than any readily available hard drive right now, and is much smaller, meaning you can pack more of them into a smaller space. If you have the cash, these drives are basically the best of both worlds, the high random IOPS of SSDs and the high capacity of hard drives. And that doesn't even include the power savings too. This whole system pulls just 75 watts, which I mean, it's no Raspberry Pi, but for an equivalent server using hard drives, that's way less power. So now you have to comment, Solidigm drives use less power. It's been 6 days, I should probably shower. Those are the rules. This leads me into the next piece of the build, and that's the case and how I'm connecting these to my motherboard. Like I mentioned, these are U.2 NVMe drives, and obviously my consumer level motherboard isn't going to have a proper way to connect them. That's where I turn to IcyDock. They make super cool expansion bays and adapters for doing crazy stuff like this. I went with their Tough Armor MB699VP-BV3, which uses the 5¼ expansion bay to give you a spot for 4 U.2 drives with an Oculink connection to each of them. Okay, cool, Oculink. Surely your motherboard doesn't have 4 Oculink ports. Well, no, it has 0. That's where this PCIe card comes into play. It's an X16 card that has 2 8i SlimSAS ports on it, 8i meaning 8 lanes each. Then what I did was buy 2 8i SlimSAS to dual 4i Oculink cables. See where I'm going with this? Our PCIe card takes the bifurcated 4x4x4x4 signal from the slot, sends that to the dual 8i SlimSAS ports. Then from there, we can use the breakout cable to each of our drives. But wait, that's only 4 drives. You said you have 5. This guy's a phony. Hold on there, buckaroo. Since we have just one more drive left and we have an open NVMe slot, and technically U.2 uses NVMe, we can just use that. Of course, there's an adapter for that, which turns an M.2 slot into a U.2 connection. And with some fancy engineering, I was able to fit that 5th drive nice and tidy into the case. Oh, the case. Yeah, this is an Inwin CE685.FH30TB3. Bro, y'all need to come up with some easier names. I went with this specifically for its modest size and the 5¼ inch expansion bay. It comes with a 300 watt power supply too, which is nice and more than I need for this build. And voila, that's it. And I may be a little biased, but I think it's pretty cool. Something about taking a regular old media center chassis and consumer level hardware and slapping like 20 grand worth of SSDs in there and using some fancy adapters to make it all work really makes me go 6 to midnight. IcyDock also has so many cool adapters out there that I'm really tempted to buy this chassis that I've seen, which is a full tower chassis with the entire front being 5¼ inch expansion bays and just getting a bunch of cool IcyDock stuff to throw in there. Let me know down in the comments if you want to see that. Okay, that's the hardware. 50% overkill, 50% consumer level, and 100% reason to remember the name. But now we have the software side of things. I'll give you guys a guess as to which operating system I installed on here. You get 5 more seconds to make your decision. Let's go! Did you guys guess Proxmox? Ha! Tricked you. I actually went with Hannah Montana OS. Okay, duh, of course I went with Proxmox. Now to fully utilize our drives, I wanted to put them all into an array to both increase the overall usable space and to give me some redundancy. There are a few ways to do this, and I'll talk about 2 of them. The first being MDADM RAID. This can be done directly in the host by installing MDADM and creating a RAID array with a single command. With 5 drives, you're probably going to go with RAID 5, which gives you 4 drives worth of usable space and 1 drive worth of redundancy. I could have gone with a full RAID 0 config for the lulz, but I wanted this to be more of a real world thing. And yes, I see the irony of saying that with a new car's worth of storage in here. After creating the array, we can slap a file system on top, and I went with good old ext4, which totally isn't going to come back to haunt me. Not at all. The last step to make it usable is to mount the file system, so I added an entry to my fstab, and boom, over 100 terabytes of storage ready to host all of my shitty YouTube videos and trash media. And like I mentioned, there are so many ways to set up and use your storage, but I want to be able to easily access it anywhere on my host, so I'm going to configure that storage as a directory mount within Proxmox. Now it shows up as usable storage for things like running VMs, containers, hosting backups, all of that stuff. All right, cool. Let's spin up an Ubuntu server VM to actually run some stuff. And since I have more storage than I possibly need, I'll give this VM a big old 50 terabyte piece of that pie. That should be plenty, right? Well, yeah, but that won't work. You see, ext4 has a max file size of 16 terabytes, and if you do the math, you'll see that 50 is actually larger than 16. So I blew up my work and redid the entire process, except now with an XFS file system. And just like that, we have an Ubuntu VM with 50 terabytes worth of data from our massive 150 terabyte MDADM array, and plenty of leftover for, I don't know, other stuff. In our VM, it's seen as raw storage, so we'd have to go in and add a file system on top of that and mount it just like we did on our host. And that's it. Is this the best way to accomplish this? Probably not, but here's the thing. If it works for you and it fits your use case, then go for it. But I'm going to show you another way to utilize our drives, and this is probably the way I'd actually do it. In Proxmox, it's fairly easy to pass through devices to a VM, so we're going to spin up a TrueNAS VM and pass our drives directly to it. This lets us utilize TrueNAS to manage our storage. There are 2 benefits to this. One is that we get to use ZFS. Yes, I know Proxmox has built-in ZFS management, but what they don't have is a proper storage sharing and backup UI, which is my second benefit, the storage management aspect of TrueNAS. After creating a TrueNAS VM and passing through our drives, we could see all of them in the UI, which means that it worked. From there, I could create a RAID Z1 array, which is equivalent to an MDADM RAID 5 array. This whole process only takes like a minute. After that, we need a way to actually use this storage outside of TrueNAS, which is where the sharing aspect comes into play. The 3 most popular ways of sharing are SMB, NFS, and iSCSI, each having their pros and cons, but for compatibility, I'm just going to use SMB. You'll want to first create a user for SMB authentication, then go into our pool and create a new dataset. I like how TrueNAS added the option to specify a new dataset for SMB use, which automatically configures it for sharing. Then just grant file system access to your user and you're done. Now you have a massive storage pool that can be accessed over the network from any machine. And like before, we can add this to the Proxmox host by selecting the CIFS option and using our credentials to access our newly created share. From here, you can do the same thing as before and add a big old chunk of raw storage to your VM and mount it and blah, blah, blah. Or you can just mount directly to the share from inside your VM. In a standard Ubuntu server install, you'll need to install CIFS utils, then create a mount point and fstab entry. Like I said, there are tons of ways to manipulate your storage to fit your needs, so just go with the way that works for you. From here, I have access directly to the ZFS dataset over SMB, which has the benefit of allowing me to easily move files over to a common location, no matter if I'm on my Windows machine or working directly in the VM. And since this is going to be a media server, I'll have to move some of my media over, only the finest. Then we get to spin up our service of choice. You may be a Jellyfin person, but I'm a Plex boy. Don't hate me. I'm also a Docker boy, as well as a Portainer boy. If you're using Docker without Portainer, what are you even doing? Creating my Plex server was as easy as pasting the standard Docker Compose template into Portainer and modifying the directory to map to our media location. That's actually it. Then we have a Plex server up and running with roughly 110 terabytes of solid state storage, just enough for your anime collection. I mentioned before that while newer AMD chips do have integrated graphics with hardware transcoding, it's just not well supported in Plex yet. So if you're looking to build a server specifically for Plex and want to use integrated graphics, maybe look for an Intel chip or just bite the bullet and buy an NVIDIA GPU. Outside of this, we're free to use this machine for whatever we want. Honestly, this thing has about as much usable storage as my main storage server, so technically, never mind. In terms of raw power, it's obviously nothing special, since the obvious draw to this setup is a massive amount of high-speed storage in a small, quiet form factor. Now, could it be smaller? My wife says no, but I think it could. So yeah, if you have like $22,000 laying around and want to mimic this build, then I'll leave links down in the description below. But this was more meant for fun, to combine super expensive enterprise storage with run-of-the-mill consumer-level hardware, then tie it all together with a weird expansion device and adapters. It was just a fun little project, man. Sue me. Let me know down in the comments what other weird combo meals you want to see, and maybe I'll try them out. If you like this video, then drop a like and subscribe if you want to see more goofy home lab stuff. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my consumer level hardware with so many cool enterprise features. Y'all are the best. And if you're still watching, you're Slim Sass. Thank you so much, and I'll see you in the next one.